Okay, so before we talk about inverse trig functions, I'm going to review inverse functions. So we say that f, so that is not a 1 over f of x, it means the inverse. So f to the minus 1, or f inverse of x, is the inverse of f of x if f inverse of f of x equals x and f of f inverse equals x. So the inverse is like the undo. Another way to think about it is if f of x equals y, then f inverse of y equals x. That's basically what this says up here. So if you do something to x, you can take the result and put it into the inverse and get back x. So we have another example here. If I have, this is f of x, I have 1, 2, 3 for x, and a, b, c for y. Then my domain would be the set 1, 2, 3. My range would be a, b, c. But over here at my inverse, I still have x and y, but my x for my inverse is my output for my regular function. So x for my inverse would be a, b, c, and my y would be 1, 2, 3. So over here, my domain is the range of my regular function. So I get domain is a, b, c, and I get range is 1, 2, 3. Okay, so another thing about inverse functions and their inverse, f has to be a one-to-one function in order to have an inverse. So if we think about the trig functions are not one-to-one. So let's pull up the graph of, this is sine, okay? And we can see that it's not one-to-one. So one-to-one means it passes the horizontal line test. So if I go through here in a horizontal fashion, I hit sine an infinite number of times. So it's not one-to-one. What I need to do is restrict the domain of sine so that it is one-to-one. So what I need to do is create, I need to restrict the domain where I get the entire range, so I get all the values from -1 to 1, but I only get them one time. I also want the interval to be compact, so all together, I don't want to have a piece here and a piece somewhere else. I want it to be a connected interval, and I want it to either contain 0 or be as close to 0 as possible. So if I look at sine, that would be this part, okay? So I throw away the rest of it. And so the domain for sine that I'm going to use is -π/2 to π/2. And my range is -1 to 1, okay? So I'm going to go back to here. And so I'm going to start off with sine, where my domain is -π/2 to π/2. And my range is -1 to 1. So when I'm also going to put 3 points of interest on here. So when x is -π/2, sine of x is -1. When x is 0, sine of x is 0. And when x is π/2, sine of π/2 is 1. Okay? So I have the ordered pairs -π/2 minus 1, 0, 0, and 1 to pi over 2. Now when I get my inverse, so we just call this inverse sign, my range and domain switch places. So my domain becomes minus 1 to 1. My range becomes minus pi over 2 to pi over 2. And all of these points switch. So I get the point minus 1 to minus pi over 2. 0, 0 stays, 0, 0. And I get pi over 2 and 1. So I'm going to go back to my graph over here. And I'm going to graph I don't know if that's going to work. We'll see. Okay, that's not what it wants. Let's try again. Okay, so sometimes you'll see on a calculator or some website a sign, and it means arc sign. And there you see the arc sign. Let me change its color. Okay, so that's my inverse sign. This point is at 1, x equals 1. X equals 1, and x equals pi over 2. So what I'm going to do is go into my, don't crash, go into my axes, and I'm going to change my y-axis to pi's and my x-axis back to units. Okay, and so we see that this is about halfway between 0 and pi, and it's right on 1. So x equals 1, y equals pi over 2. And then x equals minus 1, y equals minus pi over 2. There we go, pi over 2. Now we can see it. Now, this presents a little bit of a problem because I'm only going to get out of my, if my range is minus pi over 2 to pi over 2, here's pi over 2, and here's minus pi over 2. I only get angle measures from quadrant 1 and quadrant 4. So sine inverse only gives me angle measures from quadrant 1 and quadrant 4. In other words, I only get angle measures that are between negative pi over 2 and pi over 2. Now, if you pull out the trig table that I've been passing out for the last several weeks, you will see that there are some dark boxes on it. So if you're looking at sine, you see there's a set of 5 boxes that are outlined in black, the first 5 boxes and the last 5 boxes. That indicates the values, the angle measures that inverse sine will return. So those are the only angle measures you're going to get and you're going to get negative. When you're at the end, you're going to get minus pi over 6, minus pi over 4, minus pi over 3, and minus pi over 2. And the reason that is, go back to the graph that we had. We take the area, or the interval around 0 that gives us from -1 to 1 on the original sine function. So I'm only going to get angle measures between pi over 2 and minus pi over 2, which is the fourth quadrant. And my fourth quadrant measures are not going to be between 270 and 360 degrees. They're going to be between minus 90 and 0, or between minus pi over 2 and 0. Okay. So let's talk about the other trig functions. We're not going to do them all today. We're just going to do the sine, cosine, and tangent. So here's cosine, and I have the same problem. I want to be able to get one period. I want the range one time. So I don't want to have, I need to have a one-to-one function. So where do I define, how do I restrict my domain on cosine so that I get a one-to-one function? And so I take the part from 0 to pi. Okay, that's pi. So my restricted domain for cosine is from 0 to pi. So going back, I restrict my so there's my domain, 0 to pi, and my range is -1 to 1. I have some points of interest. So when x is 0, cosine is 1. When x is pi over 2, y is 0. And when x is pi, cosine of pi is -1. So I get the 3 points, 0, 1, pi over 2, 0, and pi -1. So when I deal with cosine inverse, what I get is my domain becomes -1, 1, and my range is 0 to pi. 3 points of interest are 1, 0, switch the coordinates here, 0, pi over 2, and -1, pi. So when I go back to my graph, here it's called a cosine for arc cosine, but it's also inverse cosine. So I'm going to go from -1 to 1, and that's what we get. So notice that I don't have any negative values. Go with red again. And so here my stuff is contained entirely in the upper half plane. So there's the point -1 pi, 0 pi, and 1, 0. Okay, so there's inverse cosine. Whoops. So cosine, or inverse cosine, is only going to return angles between 0 and pi. So it's going to return quadrant 1 and quadrant 2 angles. It's not going to return quadrant 3 or quadrant 4. Okay. And the last one, the last trig function is tangent. So let's see, I got them here. So there's tangent, and all of these are tangents, vertical asymptotes, okay? Now, it's not one-to-one, so I'm going to restrict it to just this one. And also remove all of the vertical asymptotes. Okay, so this is the part of tangent that I'm going to use. And these vertical asymptotes are at minus pi over 2 and pi over 2. So let's go back and talk about tangent. So tangent, my domain, I'm going to restrict to minus pi over 2 to pi over 2. Now the reason for the rounded braces, the rounded parentheses, is tangent is undefined at minus pi over 2 and pi over 2. So I can't actually include that in the domain without causing problems. So I have to exclude minus pi over 2 and pi over 2 from the domain, but I can use all the values right up to that. And then range goes from minus infinity to infinity. I have some vertical asymptotes here at pi over 2 and minus pi over 2. Now, when I do my inverse tangent, my range becomes, my domain is minus infinity to infinity. My domain is minus pi over 2 to pi over 2. And my vertical asymptote, a vertical asymptote, we switch x and y, so this becomes y equals pi over 2. So that's a horizontal asymptote. Y equals minus pi over 2. Okay, so going back to graph inverse tangent. There we go. Okay, let's go minus 5 to 20. All right, and this isn't centered, so it looks kind of weird. Let me change my axes. Just make the y go from oh, that's not what I wanted to do. I want to change them in. All right. So there's my thing. Let me and what happens is make it red. And then to graph my vertical asymptotes, I'm going to come down here and put y equals pi over 2, and that will give me there. Y equals minus pi over 2. That. Make it dotted. Oh, we want to include it. Come on, select. Anyway. And so we see how this is arctangent and this is tangent. So I can turn off the tangent and it's vertical asymptotes, and we see inverse tangent. So that's what inverse tangent looks like. Again, it's only going to give you values between in the first and fourth quadrant. Okay, and that's all I'm going to put on this one. I'm going to make another one for the rest of it.